Hi, I'm Richard Darst, and I'm here to tell you about what JupyterHub isn't. At one point, I started giving these talks about the opposite of the topic at hand, since that could be a little bit more enlightening. So in this talk, you'll get an insight into how Jupyter works or doesn't, several examples from my work, and hopefully you'll come away with some ideas about not just what JupyterHub does, but what kind of role it can fill for you. First though, let's start with Jupyter itself. I'm not going to go into details here since that's the topic of many other JupyterCon's talk, and I assume that you have some ideas about the general idea already. But in short, Jupyter is a project for interactive computing. The former main front end was Jupyter Notebooks, and the new main user interface is Jupyter Lab. For our purpose, they serve the same purpose. They allow the end user to interact with some computing environment through a web browser. The single user interfaces are, as the name says, for a single user. But JupyterHub, on the other hand, provides a multi-user login and resource management. A pluggable authenticator provides flexible authentication, and a pluggable spawner allocates the resources. The single user server runs inside of these with almost no practical knowledge of the hub. The hub is what people think of as a multi-user web service. So before we go on, this is a really important distinction to make, and it's really often forgotten. The notebook and the lab are for a single user, and that provides all of the main user interface that users deal with. The hub provides the minimal interface to start the single user server. It decides what starts, but then gets out of the way and directly passes through connections to the single user server. So if you have any kind of problem after the single user server starts, whether it's lab or notebook, it's not a matter of JupyterHub. Instead, it's about configuring the single user environment. You might need to adjust how the spawner starts the environment, but that's not intrinsically a hub question. So now we get to the entertaining part. What is JupyterHub not? It's not a single way of doing things. There are authenticators against the local system. For example, Unix PAM. There's authenticators against GitHub OAuth, a local password database that actually is inside the hub, unlike most of these, and so on. Then there are the spawners, which are basically the resource managers. These can interface to Docker, batch systems, remote systems via SSH, local systems via sudo or systemd, and so on. And it's not that hard to make these for yourself. So basically, once you have the JupyterHub, there's almost anything you can do with it. There's many different ways it can work under the hood. Second, JupyterHub isn't a web service. Well, I mean, of course, technically it is a web service because you access it over the web, but it's much more than that. The backend does so much more that I'd recommend to consider it as something in an entirely other category. For example, would you call an SSH server an internet server? Well, I mean, technically it is, but it fills the role of accessing some other resource, which is the server that you're actually connecting to, such that you can't consider the SSH server as the main purpose of itself. JupyterHub also isn't Jupyter. I mean, again, technically it is Jupyter, but it's not part of the Jupyter Lab or notebook interface that most people consider what Jupyter is. It is a broader part of the Jupyter project, which produces a lot of different tools for interactive computing. JupyterHub isn't an account. So you have to log in, but the actual account is stored somewhere else. Well, usually with most authenticators. And actually, you don't really necessarily need to log in. So the BinderHub service, which is a sort of radical modification of JupyterHub, has a temporary authenticator that lets you access resources without any existing account or persistence or permanent record there. So just another way that things can do anything. JupyterHub also isn't a single Python environment. You can flexibly configure your spawner to send each user to whatever environment they want, whether it's Python or otherwise. And this is excluding what Jupyter runs, and this is excluding the fact that Jupyter runs code in its own kernels, each of which can be its own environment. So for example, once the Jupyter single user server starts, it may run on some other system separate from the hub that is running in some other virtual environment or conda environment, which has all its own Python libraries installed. And then each of the Jupyter kernels which runs in there can be in yet another environment. So again, you have many different options here. JupyterHub doesn't store data. So, of course, there is some data storage there for the hub database itself, but the spawners are what sets up an environment and does store the data, or doesn't. So as we'll see shortly, my hubs that I've set up at my university have been configured to store data, and all that data is stored outside of the hub on some existing services which existed before the hub existed and will continue to exist long after the hub exists. But also the spawner can be set up without having access to any kind of temporary, or can be set up, the spawner can be set up completely temporary with no persistent data whatsoever. It's all up to you. Notice how I'm saying the spawner and not the hub? Well, you're noticing a pattern here. Almost every choice you might make about the hub is actually a choice that you make either about the authenticator or the spawner or something else. JupyterHub isn't a way to share things. So you probably see where this is going by now. So you can share things with JupyterHub, and it's a question of single user environments. Obviously, sharing data is an important part of many workflows, and it's important to do this really well. So my philosophy is always that you should use the best existing practices and not make something specific to JupyterHub. And as you might expect with the different spawners we have, you can set up data storage, well, depending on how you're running things. And this will be made more clear with some of the examples that I'll present shortly. So let's say you've invested big money into a computer cluster, a bunch of computers connected by some scheduling system for resources. This is basically your typical high-performance computing cluster. So Jupyter can provide an interface to that. Now we're getting to examples from my work at my university. This was the first hub that I've set up. So at my university, this is a part of our Slurm high-performance computing cluster, which existed long ago. And at some point, we decided we would like a better interface to it. So let's see how it works. So within JupyterHub, batch spawner integrates to this computing cluster. In our case, it's Slurm. So when a user in JupyterHub requests their single user server, it asks JupyterHub, which asks batch spawner, which goes and submits a batch job, the same way all the other users on our cluster might use it. And then that goes into the background and spawns the job. And then inside of that job, there's the single user server running. So where are the user accounts here? Well, the hub doesn't have any real knowledge of what the users are. It just basically passed straight through to the system it's running on, which is part of our cluster, which has the accounts automatically integrated into our university authentication system. That's really great. What about data storage? Well, the hub knows nothing about data storage. It just passes it off to Slurm, which starts the job. And Slurm starts the job in the exact same environment that the users have otherwise. So they have immediate access to all of their cluster data there. This is not just their personal data, but shared data. So we manage our data by group so they can share data within these groups, which are on a shared file system and controlled via Unix permissions. Pretty old-fashioned thing there, but works really well. It's not user isolation. The user isolation is run as part of Slurm itself. Also, the same goes for resource allocation. So the scheduling and the resource limitation is part of Slurm. There's really nothing really new here. What about software? Well, all the software is already installed on the hub. So I do have a separate Anaconda environment set up, which is for the single user server to run in. but all of the kernels that Jupyter uses to actually run code, those are other Python Anaconda environments we have set up that are managed by someone else and are always kept up to date with the latest software. So we don't even need to manage that. When users have their own environments they need to run, they can add their own user-specific kernel, which is stored in their home directory, and then they can access whatever software they may like that way. Let's say you're more modern and you use containers. So Kubernetes is a container orchestration system that also provides resource allocation and other fancy stuff to basically manage a bunch of resources. So at my university, sometime after the HPC Jupyter Hub, some people asked for a Jupyter Hub dedicated to teaching. So this was set up by Kubernetes. So there was someone else in my group that actually knows all about Kubernetes and set up the basics. And then I got to configuring it. So what are the things we want here? Well, we don't want new user accounts. We already have university user accounts. So we connected the hub there to the university's authentication system. So you log in exactly the same way that you log into any other system at the university. That's great. It's also not data storage. So data storage happens really cleverly. So when we were setting this up, I asked our university IT services, can I have 1 terabyte network drive for the service I'm setting up? And luckily, they're pretty good. And they said, sure. So they allocated network file system to me. And that came in and is mounted inside of the single user pods. But there's something else even more clever I did here. Within the pods, instead of all users running under the same user ID, all the pods run under the user ID of the user within the rest of the university's IT systems. So that means they also store their data on this network file system with their university UID. So that means all I can have to do is I asked them and said, oh, there's this data here. Can you mount this on classroom computers? Can you mount this on shell servers? And suddenly the data that would otherwise be contained only within JupyterHub is now available on classroom computers. Well, when people go to classrooms, or more importantly, via shell servers. So that way they can access their data via SSH. So these students are not contained or constricted to use only the Jupyter Hub to do whatever they're doing here, but it's basically one way of accessing the same data. So this is really important, I think. So by connecting this data management to the existing university systems, you can make something much bigger than you could otherwise. But it requires configuring the authenticators and spotters to do it. The typical way of Kubernetes with everyone having the same user ID inside just wouldn't work this way so well. So maybe we can take a little digression and go into what's inside of JupyterHub under the hood. So this is a somewhat complex looking diagram, but we only need to worry about the red parts here. Maybe you can find another JupyterCon talk that will talk about the rest of the parts. So the basic parts of the hub. So when someone first connects to it, it always goes to a proxy. This is called configurable HTTP proxy, but actually this is also pluggable. And you can replace it with other things that have high availability or whatever it is you may want. So the proxy, when someone first connects, directs them to JupyterHub itself, the hub. In the hub, this handles the authentication. Once the user tries to log in, it directs it to whatever other authenticator there is, which sends it to the external service to validate it and sends it back. This gives the hub a username and possibly some other authentication state. Then when the user starts the server, it goes to the spawner. And the spawner takes this authentication information and can use it or not, and then configures the environment for the user. There's also things like options forms so the user can choose what kind of single user server they want, how many resources they want, and things like that. The spawner can do whatever setup inside and basically goes and allocates some resources and then runs a command inside called JupyterHub single user. That command is what starts Jupyter Lab or Jupyter Notebook. And it goes and starts, and then there's some magic under the hood which lets it realize, oh, I'm running as part of JupyterHub. And then that server connects back to the hub and says, I'm alive. And then the hub goes to the proxy and says, okay, this user server is available. Please begin directing them to it. So then in the future, as the user is connecting to what they see as the hub, it's sending them basically straight to the single user server. And the hub has nothing to do with this whatsoever. Within the single user server, they have free reign of whatever environment they have inside of what the spawner started. And they can do everything they may need to do. So I've noticed some common patterns to problems that people often ask about. So they ask these questions about JupyterHub, but oftentimes the real problem isn't JupyterHub itself. For example, someone says something about the Jupyter Lab or Notebook doesn't work. Well, if it started, that means that the spawner actually worked. So then you have some environment. So in order to answer the question of what's wrong, you have to look at the spawner and see how it started the environment. Was it in Docker? Was it the Anaconda environment on the cluster? Was it something on the local system? And then go wherever that spawner goes and then see what could be wrong there, configure it there, and so on. Of course, sometimes you have to configure this in the hub to tell the spawner to start it slightly differently, but, well, you can figure that out when the time comes. People very often ask about sharing data, and there's nothing in the hub that is doing this. There's also nothing the hub is doing to stop you from doing this. As my example showed, this is a matter of the spawner. So in my spawners, I configured sharing data via network file systems, which you might consider to be old-fashioned, but, well, it works quite well. And when you have systems that are built on network file systems, that might be what you want to integrate with. But in the bigger picture, the question of sharing data is a question of the single user environment. Within the single user environment, if you want to share data, well, you can share Git. Share it with Git. You can have some other extensions. For example, the Jupyter Lab Google Drive extension, which lets you share data, or many other things. If it's something like the littlest Jupyter Hub, which is running on the single server, then it's a matter of configuring your server so that the user accounts can share data. What if you want to integrate with something else? For example, a learning management system with LTI. Well, an authenticator can do this, but what does integration actually mean in these kind of cases? So does it only share accounts, or does it share data or some other resources? Does the single user server communicate back with that other service? So these are all good questions. And for the most part, the hub might do this connection, but then it's up to what happens in the single user server to connect back to what you're integrating with. And that requires an extension to either Lab or Notebook. And this is sort of out of the hub's hands, but requires a bigger picture perspective of hub connects to spawner, connects to single user server, which does whatever the user wants to do. Finally, there's persistent data. So what about that? If you want persistent data, well, it's a matter for your spawners to configure. If you're using something like Kubernetes, it may destroy everything as soon as the pod stops. Or it may have a persistent volume that stores the data. It's really up to you. So by now, maybe you've decided that you want to use JupyterHub. Luckily, you have many different options. So there's some major distributions which basically package everything together. For example, there's 0 to JupyterHub with Kubernetes, which is a deployment, or as it's called in Kubernetes, a Helm chart, which can basically configure everything for you with some predefined defaults they have. And then you can go ahead and modify it a little bit more after that. This is great because you can get Kubernetes from the cloud as a service, basically. Another distribution is the latest JupyterHub, which is a script that will set up standalone JupyterHub on a server running Ubuntu with very little extra work needed from you. And then you basically have the single user or the single server JupyterHub with users mapping to local accounts on that server, which can be great for small teams. You can always build a JupyterHub from scratch, where you basically install JupyterHub, the proxy, and configure the authenticator, the spawner, all of this yourself, which is fun and isn't too hard, but you should be at least a little bit familiar with system administration. If you want to deploy to a computing cluster, in practice, you're going to probably end up doing this from scratch, because basically every cluster is different. But if you have a cluster already, you're probably pretty good with system administration, so this is probably not going to be too big of a barrier overall. My recommendation is just to be very careful, look at this upcoming conceptual introduction that I have, and then go from there. But of course, there's other options besides JupyterHub. There's other notebook options, which unfortunately I can't really tell you much about them. I don't have much experience with them. Compared to JupyterHub, there's always the classic SSH server, as I've mentioned several times. So you can run JupyterHub there and forward everything over SSH. But that's certainly a lot less easy to get set up. And also, each user has to manage it themselves. There's lots of other dashboards that are available. For example, Open On Demand. And these can provide a lot more services than just JupyterHub. So what's the moral of the story here? So JupyterHub, in my opinion, isn't a service. It's a way to access resources. And it gives you an easier interface to those existing resources than what you might already have, which increases the accessibility of your computing to more people. And if you ask me, the most important thing here isn't to give people JupyterHub and call that the end, but give people JupyterHub so they can learn to use a system and can eventually begin to explore other interfaces, which may be better to them. By configuring these authenticators and spawners, you can get whatever you may want out of it. So thank you for listening. I hope this has enlightened you a little bit.